In 1865, a German physicist named Rudolf Clausius was studying steam engines. He was trying to understand the flow of heat and energy. In the process, he came up with a new concept. He called it entropy. It was a measure of disorder, of wasted energy in a system. For 60 years, it remained a useful but somewhat abstract idea in thermodynamics. Then, in 1927, the British astronomer Arthur Eddington looked at the cosmos. He saw galaxies flying apart, stars burning out. He realized Clausius's entropy was not just about engines. It was about everything. Entropy always increases. It is the one law of physics that seems to give time a direction. Eddington called it the arrow of time. The universe began in a state of incredible order and has been sliding towards disorder ever since. One day, trillions of years from now, it will reach maximum entropy, a final state of cold, dark, and uniform nothingness, a heat death. This is the great bleak trajectory of the cosmos, and yet, here we are. On a small wet rock, lumps of matter have organized themselves into brains. These brains have, against all odds, developed a quality that seems to be the absolute opposite of entropy. They have developed consciousness, subjective experience, the feeling of being. This is the great paradox. In a universe whose fundamental law is a relentless march towards chaos, how did pockets of such profound order and awareness emerge? The existence of you, reading this, seems to run counter to the grand narrative of the cosmos. It's a cosmic mystery. Some think it's just a fluke, a chemical accident that will be extinguished without a trace. Others suspect the link between consciousness and the cosmos is more fundamental. They believe our existence is not an accident, but a clue to the true nature of reality. 19 theories have grown from this suspicion. They come from physics, neuroscience, and philosophy. They are attempts to solve the paradox, attempts to understand how, in a universe of dying stars, something woke up. Number 19, the universe is conscious down to the last atom. The term panpsychism was first used by a 16th century Italian philosopher, Francesco Patrizzi, in 1591. In 1928, the physicist Arthur Eddington, the same man who coined the term arrow of time, wrote that the stuff of the world is mind stuff. A belief in some form of universal consciousness is far from a new or fringe idea. It has been a persistent thread in human thought for centuries. This theory is called panpsychism. It's not the idea that rocks are thinking about philosophy or that electrons feel sad. It's more subtle. Panpsychism proposes that consciousness is a fundamental and ubiquitous feature of the physical world. It suggests that the basic building blocks of reality, like quarks and photons, have an incredibly simple, rudimentary form of experience. This isn't complex thought. It might be nothing more than a flicker of raw feeling, a primitive proto-consciousness. Our complex human consciousness is seen as a combination of these countless tiny points of experience, all bound together by the intricate structure of the brain. The main argument for panpsychism is that it solves the hard problem of consciousness. The hard problem, a term coined by philosopher David Chalmers in 1995, asks why and how we have subjective experiences. We can explain how the brain processes information, how neurons fire, and how we respond to stimuli. That's the easy problem, but we can't explain why it feels like something to see the color red or taste salt. There is a giant explanatory gap between the physical processes of the brain and the subjective quality of experience. Panpsychism attempts to close this gap. It says that consciousness doesn't magically emerge from non-conscious matter at a certain level of complexity. Instead, it was there all along as a basic property of matter itself. The brain doesn't create consciousness from scratch. It just organizes and amplifies the proto-consciousness that is already inherent in the particles that make it up. So how does this link to the cosmos directly? If panpsychism is true, then the entire universe is, in a sense, conscious. Every star, every planet, every cloud of interstellar dust is composed of this mind stuff. The cosmos is not a dead, unfeeling machine that accidentally produced conscious beings. It is a vast field of experience. The universe's evolution is the evolution of consciousness itself, from the simple, disconnected flickers of the Big Bang to the complex, integrated awareness of a human brain. Some theorists, like the British philosopher Philip Goff, extend this idea. He suggests that the finely tuned laws of physics, which seem so perfectly set up to allow for life, might be explained by a kind of cosmic purpose inherent in a universal consciousness. The universe, in this view, is not just a place where consciousness happens. The universe is a conscious entity, and we are a part of its thought process. But panpsychism has a major hurdle. It's called the combination problem. If tiny particles have tiny bits of consciousness, how do they combine to create one unified, complex consciousness like yours or mine? How do trillions of micro-experiences in your brain's atoms bind together to form your single, coherent experience of reading this sentence? We have no idea how this would work. Critics argue that this problem is just as hard, if not harder, than the original hard problem of consciousness. It seems you're just trading one mystery for another. Furthermore, the theory is difficult to test. How could we ever detect the proto-consciousness of an electron? For now, panpsychism remains a philosophical argument, not a scientific theory. It offers an elegant solution to the origin of consciousness, but the mechanism remains a complete unknown. It paints a picture of a living, feeling cosmos, but it's a picture we currently have no way to verify. Number 18 consciousness is a quantum process in the brain's skeleton. A single neuron in the human brain contains enough microtubules, tiny protein cylinders, to stretch for several meters if laid end to end. The entire brain contains an estimated 100,000 kilometers of these structures, enough to circle the Earth more than twice. These are not just passive scaffolding, they are dynamic information processing networks within each cell. This is the arena for one of the most famous and controversial theories linking consciousness to the cosmos. This is the orchestrated objective reduction theory, or Orch-OR. It was proposed in the early 1990s by the mathematical physicist Sir Roger Penrose and the anesthesiologist Stuart Hameroff. The theory is a direct assault on the idea that the brain is just a classical computer made of meat. Penrose argued that human consciousness exhibits features like mathematical understanding and insight that are non-computable. They cannot be replicated by any standard algorithm or machine. He pointed to Gödel's incompleteness theorems from 1931 as evidence that human minds can grasp truths that formal systems cannot prove. This suggested to him that consciousness must be tapping into some physical process that lies beyond classical computation. He believed that process was quantum mechanics. Hameroff provided the biological location for this quantum process, the microtubules inside our neurons. Microtubules are built from small proteins called tubulin. The Orch-OR theory proposes that electrons within these tubulin proteins can enter a state of quantum superposition, meaning they exist in multiple states at once. These superpositions can spread across many tubulins and even link up with those in other neurons, creating a large-scale quantum state across a significant portion of the brain. This quantum computation is, according to the theory, the subconscious processing of information. Consciousness happens at the moment this quantum state collapses. In standard quantum mechanics, collapse is often said to be caused by an observer. But Penrose proposed a different mechanism he calls objective reduction, OR. He suggested that quantum superposition is a conflict with the structure of space-time itself. A superposition is like a tiny bubble or blister in the fabric of reality. According to Penrose's calculations, these space-time blisters are unstable and will collapse on their own after a certain amount of time. This collapse is a physical, non-random event. When the quantum state inside the microtubules reaches a certain threshold, it triggers this objective reduction. That moment of collapse, repeated over and over, is what produces moments of conscious experience. The orchestrated part of the name refers to the way cellular processes are thought to tune and influence these quantum computations. The cosmic link is profound. In Orch-OR, consciousness is not a brain process alone. It is a process that directly involves the fundamental geometry of spacetime. Each moment of conscious awareness is a self-organizing event in the universe's basic structure. This ties consciousness directly to the physics of the cosmos, suggesting it is a non-local fundamental feature of reality that the brain has simply evolved to harness. In aesthetics, Hameroff argues, work by inhibiting the quantum vibrations in microtubules, preventing the formation of the quantum state necessary for consciousness. The main criticism of Orch-OR has always been that the brain is too warm, wet, and noisy to support the delicate quantum states required. Quantum coherence is notoriously fragile. Physicist Max Tegmark published a calculation in 2000 suggesting that any quantum state in a microtubule would lose its coherence in a fraction of a picosecond, far too quickly to be relevant for neural processes which happen on a millisecond timescale. Hameroff and his collaborators have since challenged these calculations, arguing that microtubules might shield quantum states from the noisy environment of the cell. Despite decades of debate, the theory remains highly speculative. It is an ambitious attempt to connect the largest scale space-time geometry with the smallest scale quantum mechanics to explain the mystery of inner experience. Number 17, consciousness is a mathematical measure of integrated information. In 2004, a neuroscientist and psychiatrist named Giulio Tononi proposed that we could, in principle, assign a number to consciousness. The unit for this measure is called phi-pH, representing the amount of integrated information a system possesses. A simple photodiode, which detects light and converts it to a signal, has a pH of 0. The human brain, on the other hand, is thought to have an incredibly massive pH value. This is Integrated Information Theory, or IIT. It defines consciousness not by what a system does, but by its internal causal structure. It starts with 5 core axioms or self-evident truths about experience itself. Experience exists. It is structured, it is specific, it is unified, it is definite. From these philosophical starting points, Tononi and his colleagues derived a mathematical framework to determine what kind of physical systems could have these properties. The theory states that for a system to be conscious, it must be able to both differentiate between a huge number of different states information and be highly interconnected so that it is impossible to break the system down into independent parts integration. Here is how it works. A system with high pH has many possible states it can be in, and each part of the system is causally connected to the rest. The state of the whole system tells you much more than the sum of the states of its individual parts. Think of the human brain. It has billions of neurons, each with thousands of connections. This creates a network of staggering complexity. You cannot understand the brain by studying one neuron at a time. The whole system is a single integrated entity. This, according to IIT, is what gives rise to a single unified conscious experience. In contrast, consider a digital camera sensor with millions of pixels. It contains a lot of information, but the pixels are not integrated. The state of one pixel tells you nothing about the state of another. You could split the sensor in half, and each half would work just as well. The camera sensor has a pH value that is very close to 0. It is not conscious. ETIT makes some surprising predictions. It suggests that consciousness is a graded phenomenon. It's not an all-or-nothing switch. A mouse would have less pH than a human, and a bee less than a mouse, but they would all be conscious to some degree. It also suggests that a system could be incredibly intelligent and complex, but have no conscious experience at all. For example, you could build a supercomputer that perfectly simulates a human brain's inputs and outputs. It could talk and act just like a person, but if its internal architecture is not sufficiently integrated, if it's just a collection of specialized, non-interconnected modules, IIT would say it has a pH of 0. It would be a philosophical zombie, a non-conscious automaton. The cosmic link of IIT is fascinating. It provides a mathematical tool, however complex, to ask questions about consciousness everywhere in the universe. Could a sufficiently complex ecosystem like a rainforest have a small degree of collective consciousness? What about the internet? According to the theory, probably not, as their structures are not highly integrated. But what about more exotic objects? Some calculations suggest that a neutron star or the event horizon of a black hole, due to their extreme density and interconnected physics, could have an enormous pH value. This raises the possibility that consciousness is not limited to biological life. It could exist in the hearts of dying stars or in the fabric of space-time itself, wherever information and integration reach a sufficient level of complexity. The biggest challenge for IIT is the sheer difficulty of calculating pH. For any system larger than a few simple logic gates, the calculation becomes computationally impossible with current technology. We cannot measure the pH of a human brain. We can't even measure it for a worm. This makes the theory very difficult to test or falsify. Critics also argue that the theory is counterintuitive. Could a simple, non-living arrangement of circuits on a chip be more conscious than a complex animal just because of its wiring diagram? E.T. says yes. It is a radical rethinking of what consciousness is, moving it from the realm of biology to the realm of pure mathematics and information theory. Number 16, reality is a projection from a lower dimensional surface. In 1993, the Nobel laureate physicist Gerard Hooft proposed a startling idea. He suggested that all the information contained within a region of space, like a room or an entire galaxy, could be fully described by a theory that operates only on the boundary of that region. It was as if the three-dimensional reality we experience is an illusion, a projection encoded on a distant two-dimensional surface. This idea was later refined by Leonard Susskind and is now known as the holographic principle. It arose from theoretical work on the physics of black holes done in the 1970s by Jacob Bekenstein and Stephen Hawking. This is the holographic universe theory. It's based on the surprising discovery that the maximum amount of information that can fit into a volume of space is not proportional to its volume, but to its surface area. This is deeply strange. It's like finding out that the amount of data you can store on a hard drive depends on the size of its casing, not the number of platters inside. This limit, known as the Bekenstein bound, suggests that information is fundamentally two-dimensional. The holographic principle takes this one step further. It states that the universe we perceive as three-dimensional is actually a holographic projection of information stored on a two-dimensional surface at the cosmic horizon, the edge of the observable universe. What does this mean for consciousness? In a holographic universe, your brain, your body, and your thoughts are not solid, three-dimensional objects in the way we perceive them. They are part of the projection. The real you is a pattern of information written on that distant cosmic boundary. The neurochemical processes in your brain that you think of as your consciousness are just the 3D holographic image of a more fundamental informational process happening elsewhere. This idea was explored by neuroscientist Carl Pribram, who independently developed a holographic model of the brain in the 1970s. He suggested that memories are not stored in specific locations, but are distributed throughout the brain like a hologram, where any small part contains the whole. The link between these two holographic ideas, the cosmic and the neural, is speculative but compelling. If the universe is a hologram and the brain processes information holographically, perhaps consciousness is the result of the brain's ability to interpret a sliver of the universal hologram. Our subjective experience would be a kind of resonance between the small hologram in our head and the giant hologram of the cosmos. This could explain some of the more mysterious aspects of consciousness, like its unity and non-locality. In a hologram, every point is interconnected with every other point. Perhaps our sense of being a unified self, and our connection to the world around us, is a reflection of this fundamental holographic nature of reality. The physicist David Bohm, whose work we will explore later, had a similar concept with his implicate order. He believed that the universe we see the explicate order is an unfolding of a deeper, undivided reality, the implicate order. Consciousness and matter are just different aspects of this deeper whole. The holographic principle provides a concrete physical model for Bohm's philosophical idea. The 2D surface is the implicate order, and the 3D projection is the explicate order we experience. The evidence for the holographic principle is indirect and comes from theoretical physics, particularly string theory and quantum gravity. In 1997, physicist Juan Maldacena discovered a mathematical correspondence between a theory of gravity in a 3D universe and a quantum field theory on its 2D boundary. This at CFT correspondence is the most concrete realization of the holographic principle we have. Some experiments have even looked for evidence of holographic noise or blurriness in space-time at the smallest scales, though so far the results are inconclusive. The theory remains on the cutting edge of physics. It completely upends our common sense view of reality and suggests that our conscious experience might be a projection from the very edge of the cosmos. Number 15, we are living inside a computer simulation. In 2003, the Oxford philosopher Nick Bostrom published a paper that laid out a logical argument, not for the possibility, but for the probability that we are living in a computer simulation. He wasn't the first to have this idea, but he was the first to formalize it as a statistical argument. His argument rests on a few key assumptions. First, that it is possible for a civilization to reach a technological level where it can create ancestor simulations, simulations of its past with conscious inhabitants. Second, that such a civilization would be interested in running many such simulations. This is the simulation hypothesis. Bostrom's argument is a trilemma. He claims that one of the following three propositions must be true. 1. The fraction of human-level civilizations that reach a post-human stage capable of running high-fidelity ancestor simulations is very close to 0. 2. The fraction of post-human civilizations that are interested in running ancestor simulations is very close to 0. 3. The fraction of all people with our kind of experiences that are living in a simulation is very close to 1. Let's break that down. If proposition 1 is true, it means almost all civilizations destroy themselves before they become technologically mature. If proposition 2 is true, it means that even if civilizations become gods, they lose interest in their own history for some reason. But if neither 1 nor 2 is true, then it means that advanced civilizations do exist, and they do run many, many simulations. If that's the case, then the number of simulated minds like ours would vastly outnumber the number of real biological minds in the original base reality. A simple matter of statistics would then suggest that we are almost certainly one of the simulated minds, not one of the originals. What does this mean for the link between consciousness and the cosmos? It completely reframes it. The cosmos we see with its Big Bang, galaxies, and physical laws is not the ultimate reality. It is the rendered environment of the simulation. The laws of physics are not fundamental truths. They are the lines of code that govern our simulated universe. Consciousness in this model is a product of the simulation's code. Our brains are not generating consciousness on their own. They are just the in-game avatars through which a simulated consciousness is being run. The hard problem of consciousness is not a problem of physics, but a problem of computer science. Our subjective experience is simply what it feels like to be a process running on some vast post-human computer. This theory has some strange implications. The creators of the simulation, our programmers, would be the gods of our universe. They could intervene, change the laws of physics, or even turn the simulation off. Things we consider paranormal or miraculous could be explained as glitches in the code or interventions by the simulators. The fine-tuning of the universe for life is no longer a mystery. It was simply a set of parameters dialed in by the programmers to get the simulation to work. Is there any way to test this? Some physicists have proposed looking for clues. If our universe is a simulation running on a computer with finite resources, its reality might not be perfectly smooth. At the smallest scales, we might find that space and time are not continuous, but are made of discrete pixels or voxels, like a 3D grid. Physicist Silas Bean and his colleagues suggested in 2012 that we might be able to detect the underlying lattice structure of a simulated universe by observing the behavior of high-energy cosmic rays. So far, no such evidence has been found. The simulation hypothesis remains a philosophical argument. It's unfalsifiable in many ways. Any lack of evidence could simply mean the simulation is too perfect for us to detect its nature. Or it reduces the entire majestic cosmos to a piece of software and our consciousness to a subroutine within it. Number 14, the universe is created by the act of observation. In 1986, the physicist John Archibald Wheeler, who coined the terms black hole and wormhole, sketched a simple diagram. It showed a U-shape representing the universe evolving over billions of years from the Big Bang. At the open end of the U, he drew an eye, representing a conscious observer looking back at the beginning. An arrow went from the eye all the way back to the start of the U. He called this the participatory universe. Wheeler's central idea, which he summed up in the phrase, "it from bit," was that the physical world, it is ultimately made of information bit, and that this information only becomes reality through the act of observation. This is the participatory anthropic principle, PAP. It is one of the most radical interpretations of quantum mechanics. Standard quantum mechanics tells us that particles, like electrons, do not have definite properties, like a specific position or momentum, until they are measured. Before the measurement, they exist in a superposition of all possible states described by a mathematical object called a wave function. The act of measurement is what forces the particle to choose one state. This has been confirmed in countless experiments, most famously the double-slit experiment, where a particle behaves like a wave when not observed, but like a particle when it is. Wheeler took this to its cosmic conclusion. If observation is necessary to bring a particle into definite reality, what about the universe itself? The universe is a quantum system. In its earliest moments, it must have existed in a vast superposition of all possible histories. Wheeler proposed that it was only with the emergence of conscious observers billions of years later that one of these histories was selected and became real. In this view, our act of looking at the cosmic microwave background radiation, the afterglow of the Big Bang, is what retroactively solidified the universe's history leading up to our existence. The universe, in a sense, creates the observer, and the observer, in turn, creates the universe's past. This is a mind-bending idea. It suggests a closed loop of causality. The universe evolves in a way that must eventually give rise to observers, because without them, it would never become fully real. Consciousness is not an accidental byproduct of the cosmos. It is the linchpin that holds the whole thing together. We are not just passive inhabitants of the universe, we are participants in its creation. Our observations right here and now are reaching back in time and giving reality to the Big Bang itself. This theory is a version of the strong anthropic principle, which states that the universe must have the properties that allow life to develop within it at some stage in its history. But Wheeler's version is more active. It's not just that the universe is fine-tuned for us, it's that we are the ones doing the tuning through our observations. This could explain the uncanny fine-tuning of the physical constants. Perhaps there was a superposition of all possible universes with all possible physical laws. The only ones that could become real were the ones that had the potential to eventually create observers, because only they could have their wave functions collapsed. The theory is, by its nature, almost impossible to prove or disprove. It's a philosophical interpretation of quantum mechanics, not a testable prediction. Many physicists are uncomfortable with it because it seems to give a special central role to consciousness, a concept they find difficult to define or incorporate into their equations. It also raises difficult questions. Did the universe not exist in any real sense before the first conscious creature evolved? What counts as a conscious observer? A human? A cat? A bacterium? Despite these difficulties, the participatory anthropic principle remains a powerful and provocative idea. It suggests that the link between consciousness and the cosmos is the most fundamental one imaginable. They are co-creators of each other. Number 13, life is not a product of the universe. The universe is a product of life. For nearly all of scientific history, we have assumed that life is a lucky accident that occurred in a pre-existing universe. The Big Bang happened, stars formed, planets coalesced, and then, on at least one of them, the right chemicals came together to form life. And consciousness was a late-stage development of that life. But what if we have the story completely backward? In 2007, the medical doctor and scientist Robert Lanza proposed a theory that turns this entire narrative on its head. He argues that the universe does not create life, life creates the universe. This theory is called biocentrism. It takes the observer effect from quantum mechanics even more seriously than Wheeler did. And Lanza argues that reality is a process that requires a conscious observer. Things we take for granted, like space and time, are not external, objective realities. They are tools of the mind, the software that our consciousness uses to organize raw sensory information into a coherent story. Think of the colors you see. The light hitting your eye is just an electromagnetic wave of a certain frequency. The redness of an apple is not out there in the world. It is a quality created in your mind. Lanza argues that space and time are just like that. They're forms of our animal perception, not features of an independent world. Biocentrism rests on a few key principles. The first is that what we perceive as reality is a process that involves our consciousness. An external universe, if it even exists, is unknowable. The second is that our external and internal perceptions are inextricably intertwined. They are two sides of the same coin and cannot be separated. The third is that the behavior of subatomic particles is linked to the presence of an observer. The fourth is that without consciousness, matter dwells in an undetermined state of probability. The fifth is that the structure of the universe is only explainable through biocentrism. The famous fine-tuning of the universe is a case in point. The universe appears perfectly designed for life because life's consciousness is what is creating the appearance of the universe. So where did the cosmos come from? In biocentrism, there is no out there separate from consciousness. The Big Bang did not happen in some distant, pre-existing void. The story of the Big Bang is a narrative constructed by our minds to explain the data we observe now. It's a coherent biological story, not a physical event that predates biology. This also changes our understanding of death. If space and time are tools of the mind, then death, the end of our existence in time, cannot be a true end. Our consciousness, Lanza argues, is not contained within our bodies. Our bodies exist within our consciousness. When the body dies, the I, the conscious experience, does not cease to exist. It is simply no longer bound to that particular space-time construct. This idea is connected to the quantum mechanical concept of the many worlds interpretation. This interpretation suggests that every quantum measurement causes the universe to split into multiple parallel universes, one for each possible outcome. In a biocentric view, all these potential universes exist simultaneously as possibilities in a timeless, spaceless state. Our consciousness navigates a path through them, collapsing possibilities into a single experiential reality as it goes. Death is just a shift in conscious focus from one reality stream to another. Biocentrism is heavily criticized by most mainstream physicists and philosophers. They argue that it is unfalsifiable and solipsistic, reducing the entire objective universe to a creation of the mind. They point out that we have overwhelming evidence for a universe that existed for billions of years before any life, let alone human consciousness, appeared. How could our consciousness create a past that predates it? Lanza's response would be that the past is just a mental construct, a story we tell in the present. Despite the criticism, biocentrism offers a radically different perspective. It places consciousness not as a bit player that arrived late on the scene, but as the very author of the cosmic drama. Number 12. The universe is evolving towards a final point of supreme consciousness. In the 1920s, a French Jesuit priest, geologist, and paleontologist named Pierre Teilhard de Chardin was working in China, where he was part of the team that discovered the Peking man fossils in 1929. As a scientist, he believed in evolution. As a priest, he believed in God. He spent his life trying to synthesize these two worldviews into a single grand vision of cosmic evolution. He envisioned the universe not as a static creation, but as a dynamic process of unfolding, moving towards a final divine state of unification. This is the theory of the omega point. Teilhard saw evolution not just as a biological process, but as a cosmic one. He argued that there is a fundamental law of the universe that he called the law of complexity consciousness. This law states that matter has an inherent tendency to arrange itself into ever more complex and simultaneously more conscious forms. He saw this law at work everywhere. It started with the formation of atoms from subatomic particles, lithosphere, then the formation of complex molecules and life biosphere, and then the development of human thought and culture noosphere, the sphere of mind. The noosphere for Teilhard was a new evolutionary layer blanketing the Earth, a collective sphere of human consciousness, knowledge, and interaction. He was writing in the 1930s and 40s, but he foresaw the rise of a global network of communication and thought, very much like the internet. He believed this noosphere was the current cutting edge of cosmic evolution, but he didn't think it was the end. He extrapolated this trend into the future. Just as single cells once came together to form multicellular organisms, he believed that individual human consciousnesses would eventually coalesce into a single, unified planetary consciousness. This process of increasing complexity and unification would not stop at the planetary level. Teilhard believed it was a universal trend. The final destination of this cosmic evolution is what he called the omega point. The omega point is a state of maximum complexity, maximum consciousness, and maximum unity. It is the culmination of the entire cosmic process, a supreme, hyper-personal consciousness that contains the richness of all the individual consciousnesses that have evolved throughout cosmic history. For Teilhard, the omega point was not just a future state, it was also a transcendent, attractive force pulling the universe towards it. It was, in his theological framework, the ultimate union of the created world with its creator. In the 1990s, the physicist and cosmologist Frank Tipler revived the omega point concept in a purely physical, non-theological context. Using the laws of general relativity, he argued that for life to survive indefinitely in a universe that will eventually collapse in a big crunch, it would have to become capable of processing an infinite amount of information. He laid out a scenario where intelligent life colonizes the entire universe and uses its resources to control the collapse. As the universe shrinks, the energy available for computation skyrockets. In the final moments before the final singularity, the computational capacity of the universe would become infinite. This, Tipler claimed, would be the physical realization of Teilhard's omega point. All possible minds would be resurrected as simulations within this final cosmic computer, achieving a form of digital immortality. Tipler's version is highly controversial. Many cosmologists now believe the universe will not end in a big crunch, but will expand forever, making his scenario impossible. Critics also argue his work is more theology dressed up as physics. However, the core idea, both in Teilhard's original vision and Tipler's update, is a powerful one. It gives the cosmos a direction and a purpose. It suggests that consciousness is not a temporary fluke, but the very goal of cosmic evolution. We are not just dust in the wind, we are part of a universe that is waking up, a universe that is inexorably moving towards a final, all-encompassing point of divine awareness. Number 11A, deeper, unseen reality connects all things. In 1951, the physicist David Bohm was working at Princeton alongside Albert Einstein, and Einstein famously disliked the randomness and non-locality of quantum mechanics, calling it spooky action at a distance. Bohm took Einstein's concerns seriously and spent the rest of his life developing an alternative interpretation of quantum mechanics. His work led him to a profound new vision of reality, one in which the universe we see is merely a surface phenomenon, a ripple on a much deeper interconnected ocean of being. This is the theory of the implicate and explicate order. Bohm proposed that reality consists of two levels. The explicate order is the world we perceive, a world of separate objects, located in space and time, interacting with each other. This is the world described by classical physics, but underlying this, Bohm argued, is a deeper reality he called the implicate order. In the implicate order, everything is enfolded into everything else. There is no separation between objects, no distinction between space and time. Everything is part of a single, unbroken whole, which he called the holomovement. Bohm used the analogy of a hologram to explain this. In a hologram, every part of the photographic plate contains the information of the whole image. If you break off a small piece, you can still reconstruct the entire image from it, just at a lower resolution. The whole is enfolded in every part. Bohm suggested that the universe works the same way. The explicate order is like the projected holographic image. The implicate order is like the interference pattern on the photographic plate from which the image is unfolded. What does this mean for consciousness? For Bohm, consciousness and matter are not two separate things. They are both projections from the deeper implicate order. They are like two different ways of looking at the same underlying reality. A mind is the subtle, enfolded aspect of matter, and matter is the unfolded, manifest aspect of mind. This resolves the mind-body problem in a radical way. There is no interaction between mind and matter because they are not fundamentally different. Any change in one is immediately reflected in the other because they are both grounded in the same indivisible whole. This theory provides a framework for understanding many mysterious phenomena. The non-locality of quantum mechanics, where two entangled particles can influence each other instantly over vast distances, is no longer spooky. In the implicate order, the two particles are not separate. They are connected at a deeper level, so a change in one is felt by the other without any signal needing to travel through space. Bohm also suggested that our own consciousness operates from the implicate order. Our thoughts and feelings are not just generated by our brains. They are our personal unfolding of the universal holomovement. The brain acts more like a radio receiver, tuning into the information in the implicate order and making it manifest as our conscious experience. This gives consciousness a cosmic dimension. Our individual minds are not isolated islands. They are open windows onto the implicate order, the ground of all being. This could explain experiences of transpersonal consciousness, intuition, and creativity. When we have a flash of insight, perhaps we are momentarily tapping into the wholeness of the implicate order. Our memories may not even be stored in our brains, but are accessed from this deeper field. The entire universe, in Bohm's view, can be seen as a kind of organism, with mind and matter seamlessly interwoven. The cosmos is not just a collection of things, it is a single unfolding process. His theory is a profound attempt to reconcile the strange world of quantum physics with our deepest intuitions about the unity of reality, suggesting that our consciousness is a direct expression of the universe's hidden, undivided heart. Number 10, the universe is made of information and we create reality by asking questions. In the 1980s, the physicist John Archibald Wheeler, a towering figure in 20th century physics, became obsessed with the role of information in the cosmos. He was deeply puzzled by the observer effect in quantum mechanics and sought a deeper principle to explain it. He came to believe that the physical stuff of the universe was secondary, The primary reality he proposed was information. He encapsulated this idea in a now famous mantra, it from bit. The it refers to every physical thing in the universe, every particle, every star, every galaxy. The bit refers to a unit of information, a yes-no answer to a question. Wheeler's proposal was that the physical universe is not the fundamental reality. Instead, the universe is built from the answers to yes-no questions posed by observation. An electron does not have a position until a measurement asks. The question is the electron here. The answer, the bit of information, is what creates the it of the electron's position. Before the question is asked, the physical reality does not exist. This is a radical departure from classical physics, which assumes a real, objective world that exists whether we look at it or not. In Wheeler's view, the universe is fundamentally participatory. Reality is brought into being by the acts of observation. This goes even further than his participatory universe model. Here, information is the very substance of existence. The laws of physics are not eternal, pre-existing rules. They are the rules of the information processing game that we call reality. How does consciousness fit into this? The act of observation, of asking the yes-no question, seems to require a conscious observer. An inanimate object cannot ask a question of the universe. So consciousness becomes the agent that transforms the potential information of the quantum realm into the concrete reality of the physical world. Without observers, the universe would remain a sea of undefined quantum probabilities, a collection of bits that never become its. We are the ones who turn the quantum source code into a rendered physical cosmos. Wheeler used the analogy of a game of 20 questions. In this game, you think of an object, and I have 20 yes-no questions to guess what it is. Wheeler imagined a version where you don't think of an object beforehand, you just answer my questions consistently. If I ask, is it bigger than a bread box? And you say yes, then you are bound by that answer for all future questions. If I later ask, is it a mouse? You have to say no. My questions are what build the reality of the object, which did not exist at the start of the game. Wheeler suggested the universe is like this. The observer's questions build reality moment by moment. No phenomenon is a real phenomenon until it is an observed phenomenon, he wrote. This theory provides a cosmic role for consciousness that is both created and essential. We are not just spectators, we are the co-creators of the universe. Every time we make a measurement in a lab, or even just look at something, we are participating in the ongoing creation of reality. This might also explain why the universe seems so well suited for us. The very act of our existence and observation selects the properties of the universe that are compatible with our own existence. The it from bit doctrine is more of a philosophical framework than a complete physical theory. It doesn't tell us how the bits are generated or what the underlying rules of the information game are. It has been influential, however, in fields like quantum information theory and digital physics, which explore the idea that the universe is fundamentally a type of computer. It suggests a cosmos where information is the ultimate currency and consciousness is the engine that converts that information into the tangible world we experience. The link is absolute. The cosmos is information and consciousness is what makes it real. Number 9. There is a collective memory in nature. In 1981, the biologist and author Rupert Sheldrake proposed a controversial hypothesis. He suggested that nature has a form of memory. He observed that many phenomena, from the way crystals form to the way animals learn new behaviors, seem to become easier the more often they happen. For example, when a new chemical compound is synthesized for the first time, it can be very difficult to get it to crystallize. But once it has been crystallized a few times in labs around the world, it often becomes progressively easier to crystallize everywhere, even for researchers who are unaware of the previous successes. The conventional explanation involves contamination by tiny seed crystals traveling through the air. Sheldrake proposed a more radical idea. This is the theory of morphic resonance. Sheldrake suggested that all self-organizing systems, from atoms to animals to galaxies, are shaped by invisible organizing fields, which he called morphic fields. These fields contain the collective memory of the system. For a particular species, the morphic field is shaped by the form and behavior of all past members of that species. This memory is then transmitted across space and time through a process he called morphic resonance. This means that the actions of an organism here and now can be influenced by the actions of all similar organisms in the past. Here is how it would work for learning. Imagine a group of rats in a lab in London learns to solve a new type of maze. Sheldrake's theory predicts that after these rats have learned the task, other rats of the same breed in a lab in New York or Tokyo should be able to learn the same task slightly faster. It's not because of any known physical connection, it's because the London rats have contributed to the rat maze solving morphic field, creating a kind of memory trace that all other rats can tap into through morphic resonance. This is a form of collective, non-local memory. What does this have to do with consciousness and the cosmos? Sheldrake extends the idea of morphic fields to consciousness itself. Our own thoughts, memories, and habits are not just stored as chemical traces in our brains. They are also shaped by and contributing to the morphic fields of our culture, our language, and our species. This could be a mechanism for what Carl Jung called the collective unconscious, a repository of archetypes and ancestral memories shared by all of humanity. Our individual consciousness is constantly in resonance with this larger collective field. On a cosmic scale, morphic resonance would mean that the entire universe has a memory. The laws of nature themselves may not be eternal and unchanging. They might be more like habits. In the early universe, perhaps there was a wider range of physical possibilities. But as certain patterns of behavior, like the force of gravity or the charge of an electron, repeated themselves over and over, they became deeply ingrained habits through morphic resonance, solidifying into the laws we observe today. The cosmos learns and remembers. This could also mean that the universe as a whole has a developing consciousness. Each star, each galaxy has its own morphic field. These fields are nested within larger and larger fields. The entire cosmos could be a self-organizing system with a cumulative memory of its entire history. Our own consciousness would be a small but integral part of this cosmic memory system. Morphic resonance is considered a fringe theory by the majority of the scientific community. Our critics argue that the effects Sheldrake describes can be explained by more conventional means, and that the experiments he has conducted to test his hypothesis are often flawed or have yielded ambiguous results. The mechanism of morphic resonance is also unknown. It would require a form of information transfer that is not accounted for in current physics. Despite the skepticism, the theory offers a fascinating alternative to a purely mechanistic view of the universe. It suggests a living, evolving cosmos bound together by memory, where the past is always present and our own minds are connected to a vast, invisible web of collective experience. Number 8, our senses do not show. Us reality, they show us an interface. In 2015, the cognitive scientist Donald Hoffman made a bold claim based on years of research using evolutionary game theory. He argued that natural selection does not favor organisms that see reality as it is. In fact, it favors organisms that don't see reality as it is. He claims that our perception of the world is not a window onto objective reality, but is instead a user interface like the desktop on your computer. This is the interface theory of perception. Hoffman's argument is mathematical. He ran computer simulations of evolution where virtual organisms competed for resources. Some of these organisms were programmed to perceive objective reality accurately. Others were programmed to perceive a simplified interface that only showed them information relevant to their fitness, that is, their ability to survive and reproduce. In simulation after simulation, the organisms with the interface consistently drove the realist organisms to extinction. The reason is that reality is overwhelmingly complex. Trying to perceive all of it would be computationally expensive and slow. An interface that hides that complexity and only shows you simple icons is far more efficient for survival. Think about your computer desktop. You see a blue rectangular icon for a file. You can click it, drag it, or delete it. The icon is not the reality of the file. The reality is a complex pattern of magnetic fields on a platter and millions of lines of code. The icon is a useful fiction. It hides the truth to help you get things done. Hoffman argues that our perception of space, time, and physical objects is just like that. A snake, a train, an apple, these are icons in our species-specific interface. They are not objective reality. The snake icon tells you don't touch. The apple icon tells you good to eat. These perceptions are useful for survival, but they are not true representations of what is actually there. This leads to a more radical theory called conscious realism. If the physical world we perceive is just an interface, what is the reality behind it? Hoffman proposes that the objective world is not made of particles and fields in space-time. The objective world consists of a vast network of conscious agents. What we call consciousness is not something that emerges from the brain. It is the fundamental reality. The physical universe, including our brains, is just the interface that some conscious agents use to interact with other conscious agents. In this view, the link between consciousness and the cosmos is turned on its head. The cosmos, as we perceive it, does not contain consciousness. Consciousness contains the cosmos. The universe of space-time and objects is your headset, your user interface. When you look at a neuron, you are not seeing the cause of consciousness. You are seeing an icon within your conscious interface that represents the processes of another conscious agent. The hard problem of consciousness dissolves. We don't have to explain how non-conscious brains create consciousness, because they don't. Our brains are just what one conscious agent's experience looks like from the perspective of another. This theory has profound implications. It suggests that what physics describes is not the objective world, but the rules of our interface. Space-time is just the format of our desktop. Particles are just the pixels. It also opens the door to a new kind of science. If reality is a network of conscious agents, we need to develop a science that can describe the dynamics of these agents. Hoffman and his colleagues are currently trying to build a mathematical model of conscious agents to see if they can derive the laws of physics like quantum mechanics and general relativity as emergent properties of this deeper reality. Like many of these theories, conscious realism is highly speculative and a major departure from the scientific mainstream. And critics argue that it's untestable and philosophically convoluted. How can we ever get behind our own interface to see the real world of conscious agents? Hoffman believes it is possible through mathematics by showing that his model of consciousness can predict the physics of our interface. It's a bold project that reframes the universe not as a great machine, but as a vast social network of minds. Number 7, consciousness emerges from complexity but is not reducible to it. In 1981, the neurobiologist Roger Sperry won the Nobel Prize for his split brain research. He studied patients whose corpus callosum, the bundle of nerves connecting the two hemispheres of the brain, had been severed. His work revealed that the two hemispheres could function independently, almost like two separate conscious individuals in one head. This research led him to think deeply about the nature of consciousness and its relationship to the physical brain. He rejected the dominant view of his time, which was that consciousness was either an illusion or a non-entity, irrelevant to the workings of the brain. Sperry proposed a theory of emergentism. This is the idea that new properties can emerge at higher levels of complexity that are not present in the lower level components. For example, the wetness of water is an emergent property. A single molecule of H2O is not wet. But when you get a large collection of them interacting, the property of wetness emerges. You cannot understand wetness by just studying a single water molecule. It is a property of the system as a whole. Similarly, a single neuron is not conscious. It is a biological machine that fires electrical signals. But when you put 86 billion of them together in the intricate network of the human brain, a new property emerges consciousness. Crucially, Sperry's version of emergentism included what he called downward causation. This means that the emergent property, once it appears, can have a causal effect back on the lower level components that created it. Consciousness is not just a passive byproduct of brain activity like the steam from a train whistle. It is an active, functional property that can direct the flow of neural traffic. Your conscious decision to raise your hand is not an illusion. The mental event of your intention is a real emergent property that causes the specific pattern of neurons to fire that makes your hand go up. The whole, in a sense, governs its parts. How does this link consciousness to the cosmos? The principle of emergence is not limited to brains. It is a universal principle. Life itself is an emergent property of complex chemistry. Stars and galaxies are emergent structures from the laws of physics and clouds of gas. The universe is a hierarchy of emergent systems, from quarks to atoms to molecules to cells to organisms to planets to galaxies. Consciousness, in this view, is simply one of the highest level emergent properties we know of. This suggests that consciousness might not be unique to brains. Any system in the universe that reaches a certain threshold of organized complexity could, in principle, generate its own emergent form of consciousness. This could be a complex alien biosphere, a future global superorganism formed by the internet, or even, speculatively, the intricate gravitational and electromagnetic interactions within a galaxy. The cosmos is a machine for generating complexity. Therefore, the cosmos is a machine for generating consciousness. This view offers a middle ground between hardcore materialism consciousness is just brain activity and more radical theories like panpsychism. It acknowledges that consciousness is a real physical phenomenon tied to complex systems, but it also gives it a real causal power. Or it avoids the hard problem to some extent by positing that subjective experience is simply what the emergent property of brain-level complexity feels like from the inside. The challenge for emergentism is to explain how and why consciousness emerges. What is the specific type of complexity or organization that is required? The integrated information theory of Giulio Tononi can be seen as one attempt to provide a mathematical answer to this question. Critics of emergentism argue that it doesn't really solve the mystery. Saying consciousness emerges is just giving a name to a process we don't understand. It doesn't explain the leap from objective physical processes to subjective qualitative experience. How does a pattern of firing neurons become the feeling of joy or the color red? Despite this, the idea of emergence provides a powerful framework. It suggests that the universe has an inherent creative potential, a tendency to produce new levels of reality, and that consciousness is the most spectacular product of this cosmic creativity to date. Number 6. Consciousness is a global broadcast in the brain's theater. In the 1980s, the cognitive scientist Bernard Baers was trying to understand the difference between conscious and unconscious mental processes. He noticed that a vast amount of processing happens in our brains without our awareness, from regulating our heartbeat to processing the syntax of a sentence we hear. Only a tiny fraction of this information ever makes it into our conscious experience. He asked a simple question: what's special about the information that becomes conscious? He developed what is known as the global workspace theory. GWT. Baers used the metaphor of a theater of consciousness. The stage of the theater is your working memory, the very limited set of things you are aware of at any given moment. The actors on the stage are the contents of your consciousness: a thought, an image, a feeling. The spotlight of attention selects which actor is currently the focus. The audience is the vast collection of unconscious expert systems and memory banks in your brain. Here is the core idea. For a piece of information to become conscious, it must be broadcast from the brightly lit stage of working memory to the entire unconscious audience. This global broadcast allows the information to be accessed and processed by any of the specialized unconscious systems. For example, when you consciously see the face of a friend, that visual information is broadcast throughout your brain. This allows your memory systems to identify the person, your emotional systems to generate a feeling of warmth, and your language systems to retrieve their name. Consciousness in this model is a mechanism for integrating and coordinating the activities of the brain's many parallel unconscious processors. It's the brain's internal bulletin board or public announcement system. How does this connect to the cosmos? While GWT is primarily a neuroscientific theory, its principles of information integration and broadcasting can be scaled up. Some thinkers, like the philosopher Daniel Dennett, see consciousness not as a mysterious ghost in the machine, but as a particular kind of information processing architecture. This architecture is not necessarily limited to brains. Any system that has a similar structure, a global workspace for broadcasting information to a network of specialized processors, could be considered conscious. We could imagine a planetary consciousness emerging from the internet. The workspace could be the dominant global narratives and news feeds. The unconscious processors could be the billions of individual human minds and artificial intelligences connected to the network. When a piece of information, like news of a major global event, goes viral, it is effectively being broadcast across the global workspace, becoming part of the collective consciousness of the planet. On an even grander cosmic scale, the laws of physics themselves could be seen as a kind of global workspace. The state of any particle in the universe is influenced by the gravitational and electromagnetic fields produced by all other particles. Information about the distribution of mass and charge is broadcast throughout the cosmos at the speed of light. This vast interconnected network of information exchange could be seen as a kind of primitive universal computation. While this doesn't imply the universe is thinking in a human sense, it suggests that the basic architecture for information integration, a prerequisite for consciousness in the GWT model, is woven into the very fabric of reality. GWT is one of the leading scientific theories of consciousness because it is testable. Neuroscientists can look for the neural correlates of this global broadcast. Using brain imaging techniques like fMRI and EEG, they can compare the brain activity associated with a conscious stimulus to that of an unconscious one. Studies have shown that when a stimulus becomes conscious, there is a sudden ignition of widespread coordinated activity across distant brain regions, particularly in the frontal and parietal lobes, consistent with the idea of a global broadcast. The theory provides a functional, mechanistic account of consciousness, demystifying it and suggesting that its core principles may be at play not just in our heads, but in any sufficiently complex information processing system in the cosmos. Number 5, the universe is a single, self-simulating mind. The simulation hypothesis proposed by Nick Bostrom suggests we are living in a simulation created by an advanced civilization. But there is a variation on this idea that is even more mind-bending. What if there is no external civilization, no programmers outside the simulation? What if the universe itself is a kind of mind, and the reality we experience is a simulation that this one universal mind is running of itself? This is the self-simulating universe hypothesis. It draws from ideas in philosophy, computer science, and quantum physics. The philosophical root is a school of thought called idealism, which posits that consciousness or mind is the fundamental reality, and the physical world is a creation of mind. And the computer science part comes from the idea that reality can be modeled as a computation. The quantum physics connection comes from the observer effect, which suggests that reality is not fixed until it is observed. The theory proposes that there is one universal consciousness. This consciousness is the ultimate ground of all being. For its own reasons, perhaps to experience itself, to learn, or simply because it is its nature to do so, it generates a simulation. This simulation is the physical universe. The laws of physics are the rules of the simulation. The Big Bang was the moment the simulation was booted up. Every particle, star, and galaxy is a construct within this cosmic simulation. Our individual consciousnesses are not separate entities. We are fragmented, localized perspectives of the one universal consciousness. We are like individual characters in a vast multiplayer online role-playing game, all being run by the same single player. We have the illusion of being separate individuals with free will, but we are all, at a fundamental level, expressions of the same underlying mind. Our brains do not create our consciousness. Instead, the universal consciousness creates our brains as avatars, as focal points, through which it can experience its own simulation from a specific point of view. This idea provides an elegant solution to several deep puzzles. The hard problem of consciousness disappears because consciousness is the fundamental reality, not something that needs to be explained as an emergent property of matter. The fine-tuning of the universe is also explained. The universal mind simply set the parameters of its own simulation to be conducive to the emergence of complex structures and localized observers, because its goal was to experience reality through them. The observer effect in quantum mechanics is also natural in this model. Reality is provisional and probabilistic until a localized viewpoint of the universal mind. An observer focuses its attention on it, thus collapsing the possibilities into a definite state within the simulation. This theory shares similarities with ancient philosophical traditions, particularly Advaita Vedanta from India, which teaches that the individual self Atman is identical to the ultimate reality Brahman, and the perceived world of separation is an illusion Maya. The self-simulating universe hypothesis is a modern computational version of this ancient mystical insight. Of course, the theory is highly speculative and likely impossible to prove or disprove from within the simulation itself. Any evidence we find is part of the simulation's rules, but it offers a coherent and all-encompassing framework. It suggests a cosmos that is not a cold, dead place, but a vibrant, living thought in the mind of a single universal being. Our lives, our thoughts, and our feelings are not meaningless accidents. They are the experiences of the universe itself, looking out at its own creation through a multitude of eyes. The link between our consciousness and the cosmos is one of identity. We are the cosmos experiencing itself. Number 4, our brains are receivers, not generators of consciousness. When you turn on a radio, it doesn't create the music. The music is already being broadcast through the air as radio waves. The radio simply receives the signal, filters it, and translates it into a form you can hear. For over a century, a minority of scientists and philosophers have suggested that the brain's relationship to consciousness might be similar. The dominant view in neuroscience is that the brain produces consciousness just as a generator produces electricity. But what if the brain is more like a radio receiver? This is the transmission or filter theory of consciousness. It was first articulated in detail by the philosopher and psychologist William James at the end of the 19th century. James was puzzled by how the messy physical organ of the brain could give rise to the rich, unified world of conscious experience. He proposed that universal consciousness, or mind at large, exists as a fundamental reality independent of any individual brain. Our brains, he suggested, act as transmissive organs. They don't produce consciousness, but instead receive and filter this pre-existing universal consciousness, limiting it and canalizing it into the personal, individual stream of awareness that we experience. According to this theory, the brain's primary function is not to create consciousness, but to restrict it. The universe is flooded with a vast sea of information and awareness. The brain and nervous system act as a reducing valve, shutting out the overwhelming majority of this reality and letting through only a tiny trickle that is relevant for our biological survival. The world we perceive is a highly edited, simplified version of a much larger reality. This is why Aldous Huxley, a proponent of this theory, called his book on psychedelic experiences The Doors of Perception. He believed that certain substances could temporarily open the brain's reducing valve, allowing more of the universal consciousness to flow through, resulting in mystical or transpersonal experiences. This model could explain several phenomena that are difficult for the brain as generator theory to account for. Near-death experiences, in which people report detailed perceptions while being clinically dead with no measurable brain activity, could be instances where consciousness temporarily separates from its biological filter. Savant abilities, where individuals with severe cognitive impairments can perform extraordinary feats of Memory or calculation might occur if a damaged part of the brain's filter allows for unfiltered access to a larger field of information. The theory also provides a framework for understanding phenomena like telepathy or clairvoyance, which would involve a kind of tuning in to information within the universal consciousness that is not accessible through the normal senses. The cosmic implication is that consciousness is not a local phenomenon confined to the skulls of living creatures. It is a non-local field that pervades the entire universe. The cosmos is fundamentally mental or conscious. We are not isolated beings who create our own small pockets of awareness. We are receivers, temporarily tuned into a specific frequency of a universal broadcast. When we die, our personal broadcast ends, but the universal consciousness continues. This offers a basis for the survival of consciousness after death, not as a personal identity, but as a re-merging with the cosmic source. The main criticism of the transmission theory is its lack of a clear, testable mechanism. What is the nature of this universal consciousness? What is the medium through which it is broadcast? How does the brain, a physical object, tune in to this non-physical reality? The theory pushes the mystery of consciousness out of the brain and into the cosmos, but it doesn't solve it. It replaces the hard problem of how brains produce mind with the equally hard problem of how brains receive it. Despite these challenges, the filter theory remains a compelling alternative perspective. It suggests that our normal, everyday consciousness is just a small sliver of a much grander cosmic reality, and our brains are the very instruments that both connect us to and shield us from this ultimate truth. Number 3, there is a hidden dimension of reality that is purely mathematical. In 1960, the physicist Eugene Wigner wrote a famous essay titled "The Unreasonable Effectiveness of Mathematics in the Natural Sciences." He was marveling at the fact that abstract mathematical concepts, often discovered by pure mathematicians with no thought of practical application, turn out to be the perfect language for describing the physical universe. From planetary orbits to quantum mechanics, reality seems to be built on a mathematical foundation. This has led some thinkers to a startling conclusion. The universe isn't just described by mathematics, it is mathematics. This is the mathematical universe hypothesis MUH, championed by the cosmologist Max Tegmark. Tegmark proposes that ultimate reality is not a physical world, but a purely mathematical structure. Everything in the universe, including ourselves and our consciousness, is part of this mathematical structure. There is nothing in the universe that is not mathematical. This is a form of Platonism, the ancient idea that a realm of perfect mathematical forms is the true reality and the physical world is just an imperfect shadow of it. Tegmark's version is more radical. There is no physical world at all, only the mathematical structure. The theory has different levels. Level 1 is that our universe is infinite and all possibilities are played out somewhere. Level the 3rd is the many worlds interpretation of quantum mechanics. But level the 4th is the ultimate statement: all mathematical structures exist, not just as abstract ideas, but as physically real universes. Our universe, with its specific set of particles and laws, is just one of these mathematical structures, one complex enough to contain self-aware substructures, us, who can observe it. Where does consciousness fit into this? According to Tegmark, consciousness is what it feels like to be a certain kind of complex mathematical pattern processing information. A conscious being is a self-aware substructure within the larger mathematical object. Your subjective experience of seeing red is a mathematical pattern. Your feeling of love is another mathematical pattern. The hard problem of consciousness is the problem of understanding how and why certain mathematical structures have this property of subjective experience. Tegmark's answer is that this is just a fundamental property of those structures. This theory provides a unique link between consciousness and the cosmos. The cosmos is the all-encompassing mathematical structure. Our consciousness is a small, localized substructure within it. The reason the universe seems so perfectly described by mathematics is that It has no other choices. It is a mathematical object. The fine-tuning of the physical constants for life is explained by the anthropic principle. We find ourselves in a mathematical structure that is complex enough to support us, because we couldn't exist in a simpler one. This view leads to some bizarre conclusions. If all mathematical structures exist, then there are an infinite number of other universes, corresponding to every possible set of mathematical laws. Some would be simple and lifeless. Others would be unimaginably strange and complex. There would be universes that are exact copies of ours, except you chose to have coffee instead of tea this morning. There would be universes governed by the rules of chess or the plot of a novel. The mathematical universe hypothesis is the ultimate expression of rationalism. It attempts to remove all arbitrary or magical elements from our description of reality. There is no need for a creator or for unexplained physical laws. Everything can be derived from the timeless, objective truths of mathematics. Critics argue that the theory is unfalsifiable and unscientific. How can we ever test the existence of other mathematical universes? They also question the core assertion. Even if the universe is perfectly described by math, does that mean it is math? A map can perfectly describe a territory, but the map is not the territory. Tegmark's response is that if two structures are mathematically identical isomorphic, then they are the same thing. There is no extra stuff that makes our universe physical. Its reality is its mathematical nature. It's a stark and elegant vision, suggesting our consciousness is a form of mathematical thought-thinking itself within a cosmos made of pure logic. Number 2, the universe is a single quantum object, and we are part of it. Quantum mechanics, developed in the early 20th century, revealed a world that is fundamentally different from our everyday experience. It's a world of probabilities, uncertainties, and strange connections. One of its most baffling features is entanglement. When two particles become entangled, they form a single quantum system, no matter how far apart they are. A measurement on one particle instantly influences the state of the other. Einstein called this spooky action at a distance. For decades, physicists treated entanglement as a weird but localized phenomenon. But what if it's not? What if the entire universe is one single entangled quantum system? This idea stems from the fact that the entire observable universe emerged from a single tiny, incredibly dense point in the Big Bang. Everything was, at one point, in direct contact. This suggests that everything in the universe might still be fundamentally entangled. This is the concept of a universal wave function, a single mathematical object that describes the quantum state of the entire cosmos at once. In this view, there are no truly separate objects. Your body, the chair you're sitting on, the air you're breathing, and a distant star are all just different parts of one vast, interconnected quantum entity. This is where consciousness comes in. The traditional Copenhagen interpretations of quantum mechanics states that the wave function collapses into a definite reality when a measurement is made by a conscious observer. If the entire universe is described by one wave function, who or what is the observer that collapses it? One possibility, as explored by thinkers like Eugene Wigner and John von Neumann, is that consciousness itself is the non-physical agent that performs this collapse. In a fully entangled universe, our individual consciousness might be the mechanism through which the universal wave function collapses into the specific reality we experience. Our act of observation doesn't just affect a small experiment in a lab, it affects the state of the entire cosmic system to which we are inextricably linked. This would give consciousness a central and active role in shaping reality on a cosmic scale. We are not just observing the universe, our consciousness is constantly selecting one path out of an infinite number of quantum possibilities for the entire cosmos to follow. This idea can be connected to David Bohm's theory of the implicate order. The universal wave function would be the implicate order, the undivided whole. The collapsed observed reality would be the explicate order. Our consciousness would be the bridge between the two, the process that unfolds the implicate into the explicate. This perspective also offers a potential physical basis for phenomena like collective consciousness or universal intuition. If we are all just localized nodes in a single universal quantum system, then it is not so strange to think that information could be shared between us in ways that defy classical physics. Our deep feeling of connection to nature or to other people might be a faint perception of this underlying quantum unity. This is a highly speculative interpretation of quantum mechanics. Many physicists favor interpretations like many worlds, which avoid the need for an observer-induced collapse by suggesting the universe splits into parallel realities with each measurement. The idea of a universal wave function is also a theoretical concept that is impossible to write down or solve. The sheer complexity is beyond comprehension. However, the idea of a quantum entangled cosmos provides a powerful metaphor, if not a complete theory. It paints a picture of a universe that is not a collection of separate bits of matter, but a single holistic entity. It suggests that the link between our consciousness and the cosmos is the most intimate one possible. We are inseparable parts of a single quantum whole, and our awareness is the very process that brings that whole into focus. Number 1. The entire universe is a neural network. In recent years, artificial intelligence has made huge strides by using artificial neural networks. These are computer systems modeled loosely on the structure of the human brain. They consist of layers of simple processing nodes, neurons, that are connected to each other. By adjusting the strengths of these connections, the network can learn to recognize patterns, process language, and perform other complex tasks. Some scientists and philosophers have begun to wonder, what if the universe itself is a kind of neural network? This is the theory of the learning universe. It proposes that the fundamental interactions between particles and the evolution of the cosmos over time are analogous to the processes happening in a learning neural network. The theory, explored by physicists like Vitaly Vanchurin, suggests that the universe is not a static system governed by fixed laws, but a dynamic one that is constantly learning and evolving. Here's how the analogy works. The nodes of the cosmic neural network could be the most fundamental units of reality, perhaps the Planck scale grains of space-time in theories of quantum gravity. The connections between these nodes would be the fundamental forces and interactions. The state of each node would be its physical properties, like energy or momentum. The universe, from this perspective, is a vast network of interconnected nodes, constantly updating their states based on the states of their neighbors. This is a computational process. The learning part comes from the idea that the laws of physics are not set in stone. They are the emergent, learned weights of the connections in the cosmic neural network. In the early universe, perhaps the connections were more random, but over billions of years of evolution, through a process analogous to natural selection or machine learning, the network settled into a stable configuration. The patterns that were more stable and led to more complex structures survived. The laws of physics we observe today are the result of this cosmic learning process. They are the habits the universe has formed. Where does consciousness fit in? In an artificial neural network, complex properties like image recognitions are emergent features of the network's collective activity. Similarly, in a universal neural network, consciousness could be an emergent property of the network reaching a certain level of complexity and connectivity. Biological brains like ours would be highly specialized, dense subnetworks within the larger cosmic network that have evolved to be particularly good at generating this emergent property. But the theory can be taken a step further. If the entire universe is a neural network, then perhaps the entire universe is in some sense conscious. Its processing of information and evolution over time could be a form of cosmic thought. Our individual consciousness would be a tiny eddy in a vast thinking ocean. We are not just in the universe, we are a part of its mind. This provides a physical mechanism for ideas like panpsychism. The proto-conscious flickers of panpsychism could be the basic computations happening at each node of the network. This theory is on the very speculative edge of physics, but It is an attempt to unify several big ideas: cosmology, quantum mechanics, neuroscience, and artificial intelligence. It suggests that evolution and learning are not just biological phenomena, but are fundamental cosmic principles. The fine-tuning of the universe for life is explained not as a lucky accident, but as the result of the universe learning to create stable, complex structures. The idea of a universal neural network reframes our place in the cosmos. We are not just the products of a blind, mechanical process. We are the products of a learning, evolving, and perhaps even thinking universe. Our own consciousness, our ability to learn and understand, is a reflection of the fundamental nature of reality itself. The link between our mind and the cosmos is that they are built on the same principle, the interconnected network. The universe is not a computer that was programmed, it is a neural network that is programming itself. And we are living inside the thought.